Hello friends, welcome back to Civil Depth BD. Today we will model cantilever slabs for this structure. At story 1, that means for ground floor, there is no necessity of cantilever slabs. At story 2, we have to model cantilever slabs. Let's go to AutoCAD. Here we can see ground floor roof beam layout plan. At first, check the dimension of first cantilever slab. Here we can see at y direction the dimension is 4 feet and for x direction the dimension is 7 feet. Okay. Now what will we do? Go to story 2, go to replicate command for y direction, take minus 4 feet, apply, change the property of this beam. Initially this is a structural beam. So what will we do? We will select the beam and right click of mouse. From the section property, we will assign none. That means this is not a structural beam anymore, but here the color of the structural beam and the none line almost similar. So what will we do? We will go to the options, go to graphics color, then go to output. Again go to options, graphics color display. Actually, from here select any color that you want. Now you can see we can differentiate between the structural beam and the none line so easily. Now we will draw another none line. So go to draw beam. From the property we have to select none. Now draw a none line from this point to this point. Again select this beam, replicate the none line at x direction up to 7 feet. Click on apply. Now we have to divide this frame, select the full frame and this joint, go to divide frame, break at intersection with selected frame and joints, apply, OK. Select the beam, delete this one. Here we do not need any beam. Now we will model cantilever slab. Select the draw floor. From the property, select slab 6 inches one way. You can model shell type of slab. But here I am interested to use membrane slab. That means slab 6 inches one way in our case. Another thing here, by default, ETABS will generate the local axis at x direction, that means for 0 degree, but here our slab will be we are interested to distribute the load at y direction, that means for this column and this beam, so we have used local axis as 90 degree. If we use 0 degree here, local axis will be at x direction. Because we have used 90 degree, that's why load will be carried by this beam and this column or this column. Okay, here. Now again go to AutoCAD. Then we have to check the distance. This portion 10 inches. Okay, fine. Again this one 4 feet 5 inches. So what we can do, we can select the beam 0, replicate this one at y direction up to 10 inches, apply. Now what we can do, we can draw another none line here, but we can't snap the joint. So what we have to do, we have to select this beam, also this none line, then go to divide frame, apply. Now okay, select, delete the beam. Here we don't need to draw any more none line. We can complete our work by this divided line. Now replicate this one at x direction up to 4 feet 5 inches. 4 feet 5 inches. Apply. draw a null line here also. At first, join these two frames. Now draw a cantilever slab here. I know this is not a one-way slab, but I am interested to pass the load in y direction. That's why here we are using local axis 90 degree. Again, check the dimension here. This one is 3 feet and this is 5 feet 8 inches. Okay, fine. Select the beam, replicate this one to -3 feet, apply. Okay, now draw a null line here. Let's check from the center point. Okay, fine. From the center of this column, the dimension of this slab is 4 feet 11 inches. That's okay. Or we can replicate. We can replicate this null line also. So what will we do? We will select the line, then place here 0, then select pick 2 points in the model. From we will replicate this line from this point to this point. Okay, click on apply. Now we can delete this one. From this point, the dimension of the slab is 5 feet 8 inches. So put 0 for the dx. For y direction, sorry, for x direction we have to put the value 5 feet 8 inches. Click on apply. Then model the slab. Delete this structural beam. If we select Control and press here, we will see there we have two lines at the same position. So we have to delete one line. We will delete this line L8. We have selected the small null line. Now we will delete this one. Okay. Now if we press Control in our keyboard and click here, we will see there have only one line. We can't provide two null object or any object at the same position at a time. Okay. AutoCAD ETABS will show warning if we do so. Now again draw a frame here. Now go to AutoCAD plan again. Here we can see 10 inches, then 12 feet 9 inches. Okay, we will select this one, replicate this one in y direction up to -10 inches. Okay, now we will draw a null line here, but we can't snap this one again. So we will divide. Go to divide frame. Now we can delete this thing. We can select this divided line. Here the distance was 12 feet 9 inches. Put 0 here, 12 feet 9 inches. Click on apply, and we can see that there may have some okay, we will model this one by this way. Select this one, then select pick 2 points in the model. From this joint we will replicate this one at this grid point. Click on apply. Okay, now what we can do, we can model a null line here also. Then we will model slab here. After that, we can see here we have a distance of 3 feet, then 5 feet 8 inches. Okay, we will select this one, go to replicate command, 0, -3 feet, apply, draw a beam here, actually non-line. Then we have to check the distance. This is 5 feet 8 inches. Select this one, replicate the beam, 5 feet 8 inches, apply, delete this one, draw a non-line here, then draw necessary slab. After that, okay, here we can join these two frames, right? So select them and go to join frame. Again, we can see here we have a distance of 10 inches maybe. Then we have a distance of 4 feet 5 inches for x direction. Select this one, 0, -10 inches, apply, select this one and this one, then divide the frame, delete unnecessary structural beam. After that, replicate this one up to 4 feet 5 inches maybe. 4 feet 5 inches, click on apply. Now we will join this. Again, what will we do? We have a distance of this one is not very mandatory, but this direction is important, 4 feet. So select this one, replicate, y direction 4 feet, apply, okay, pick 2 points, select this one and delete. We can model the slab now. Also remember that at this position here we have 2 lines at a time. Again, select by using Control L12F. This is the small one. Select the small one, then delete. So we have completed modeling of cantilever slab for story 2. Here we also have a cantilever slab at the position of landing, but we will model this one when we will model a staircase for this structure. Now go to a typical floor roof beam layout plan. Here we can see the distance is 4 feet. Again, this one 7 feet. That means similar actually. So if we need, we can replicate these things. Select this one. Here you can see. Now go to replicate command. Then go to story. At story 2, click on apply. Okay. Now go to the plan view of story 2. Sorry. Extremely sorry. We have to replicate them at story 3 actually, right? Let's check if we have. Okay. Select them, go to replicate command, go to story 3, click on apply. Now lines are replicated. Here you can see. Now model these one-way slab. Again, I am telling you can model here a two-way slab by considering the shell. Okay. Now what will we do? We can see there we have again 10 inches with 4 feet 4 inches this time, almost similar. So we will replicate these two lines at story 3. Now go to story 3. Here we will divide the frame, or we can check the okay. So no need to divide. Now check the dimension of one-way slab for this panel. Here the distance is 3 feet. You can also consider from the center of the beam. Also important thing, we can add more 6 inches for all the panels, but here I have already done, so I will not revise this one. Now let's check the distance. This is the distance is 5 feet 5 inches. Select this one, replicate, x direction 0, y direction 3 feet minus 3 feet, apply, okay, 5 feet 5, but this time we will take pick 2 points from this point to this grid ID, click on apply, delete this unnecessary structural beam, draw a null line here, again draw a slab, okay. Now go for the next panel. Here we can see the total distance is 6 feet, and for the x direction the distance is 13 feet 3 inches. Okay, so what will we do? We will select this one, go to replicate, 0 minus 6 feet, click on apply. Now delete this line. We can draw a single line for both the panel. Okay, select this one, put 0 for dy, 13 feet 3 inches, click on apply. Okay, now we can delete this portion and draw a null line here. Then go to draw slab. Okay, again go here and check the distance. This is a 3 feet and this one is 5 feet 5 inches. So select the beam, or we can go with this one also. Place 0 here, minus 3 feet, click on apply. We can, what we can do, we can select this two frame, then go to divide frame, click on apply, select this one, replicate this one up to 5 feet 5 inches, 0, 5 feet 5 inches, click on apply. Now at first initially select the structural beams and delete them. Now select this joint and this joint. Again draw the slab. Now here we can see 10 inches, maybe the similar thing, 10 inches, and for x direction 4 feet 5 inches. Okay, select the frame, replicate this one up to minus 10 inches, select these two, divide, delete, also delete this structural beam. What was the distance? 4 feet 5 inches. So 0, 4 feet 5 inches. Click on apply. Draw a non-line here. Again, draw a slab. We can join these two panels. Maybe there also we can join the frames. Now finally check the distance, maybe similar 4 feet. Okay, select this one, replicate at y direction up to minus 4 feet. Click on apply. Select the, now we can delete this beam. Select this one, select pick 2 points. Apply, okay. We can model a non-line here. Now we can model slab. Finally, note that if we press Ctrl at keyboard and press here or select here, we will see there we have two lines at the same position. So we need to delete, but ETABS not snapping. Okay, let's check. This one is L30 and this one is L28. Small one is L28. So delete this one. Okay, at first I will check if there is any warning. So go to Analyze, check Model. Okay, we can see at L17 and L1 at story 2, L17 and L1 are overlapping. So we have to find the model. We have to find the level of the lines. So go to Set Display Options, then go to Objects Assignment, Frame Assignment, Level, Apply. Okay, maybe L17, 16 here. Sorry, 19, this one at story 2 actually, right? L17, 13. Let me check again, Analyze, check Model. L17 and L1, okay. Here, maybe. I will click here. Here we can see there we have two lines. By mistake, we didn't delete the smallest one or the smallest panel. Now we can delete this one. Now we don't need level of frame anymore. Click on Apply. Now go to Analyze, check Model. Now we can see there is no warning in our model. Now we will select these slab panel and non-lines. Okay, at first we will select non-lines only so that we can understand if there is any mistake in our selection. Now we will replicate them. Go to replicate commands, go to story 4, 5 and 6, click on apply. Now go to okay, we can see we have done the replication without any mistake. Now we can select the slab panels. Now we can select the slab panels. Again, go to replicate command, go to story 4, 5 and 6, click on apply. Okay, for story 4, this is the view, 5 and 6. Now again check if there is any warning. Hopefully there is no warning, but check again. Okay, there is no warning. That means today we have completed modeling of cantilever slabs for this structure. In the next tutorial, we will see how we can model a staircase in this structure. That's all for today. See you in the next tutorial. Thank you.